Good morning, dear students. Okay, so in the last class, we have completed aldehydes and ketones, right? So did you go through whatever the this were told name reactions? Yes, any doubts in that aldehydes and ketones? So did you practice those reactions? Yes. So you have to practice it every day. Okay. So all the name reactions are very important. So I have been telling you then and there itself. So whichever questions are important, right? So how it is asked. So I have everything I have mentioned to you, right? So please keep on practicing those. Okay, understand those name reactions. Okay, so don't get confused. So there will be more confusion. So for that only practice, you have to write and practice. Okay, so understand the reaction and write and practice the name reactions. Okay, so today we are going to start with carboxylic acids. Okay, so aldehydes and ketones we have completed. So the last part from this chapter is carboxylic acid, right? So carboxylic acids, what are carboxylic acids? So organic compounds which containing a carboxyl group, right? So aldehydes and ketone, what it contains? It contains a carbonyl group, right? Here it contains a carboxyl group. What it contains? A carboxyl group. So it contains a carboxyl group. So organic compounds which contains carboxyl groups, okay, that is a carboxyl functional group. They are called as the carboxylic acid. Okay, they are called as what? Carboxylic acids. So how they are generally represented? They are generally represented as RCOH. Okay, they are generally represented as RCOH. Now, what is this R? R can be a aliphatic. Okay, aliphatic means what? Either a alkyl group can be attached to a RCOH group, that is for a carboxylic group, or a aromatic. It can be a alkyl group or it can be a aryl group. Aryl means what? Any ring, aromatic ring. Okay. So carboxylic acids, they can be, your R can be a alkyl group, that is a aliphatic carboxylic acid. When R, that is your alkyl, R is a alkyl group, if it is attached to a carboxylic acid, then it results into aliphatic carboxylic acid. Okay. Or when your R, if it is a aromatic ring, okay, if it is a aromatic ring, then it is aromatic carboxylic acid. Okay, so these are the what you can say, how these are classified. Okay, now further, so whenever you have so there are large number of carboxylic acid found in nature. So there are many number of carboxylic acid found in the nature. So the aliphatic carboxylic acid from C12, so carbon 12 to carbon 18, they are termed as fatty acids. They are termed as what? Fatty acids. So if the carbon chain of the carboxylic, that is aliphatic carboxylic acid, it is from C12 to C18. Okay, C12, that is the number of carbon atoms are, if they are from C12 to C18, then they are termed as fatty acid. So this was a brief introduction about carboxylic acid. Okay, so what are carboxylic acids? So compounds which are containing a carboxyl functional group. What is a carboxyl functional group? COOH. Okay, so if the carboxyl group, if it is attached to a R, that is a alkyl group, then they are termed as aliphatic carboxylic acid. If your carboxylic group is attached to a aryl group, then they are termed as aromatic carboxylic acid. Okay, so this was a brief introduction about your carboxylic acids. Okay, so let us go further. So next, what is the next step? We are going to understand how to name these compounds. Okay, naming the compounds is very important, right? So naming the compounds are very important. So next is IUPAC, nomenclature of carboxylic acid. Next is what? Nomenclature of carboxylic acid. So we are going to understand the IUPAC system. Okay, so in organic chemistry, IUPAC system is very important, right? How to name the compounds? It is through the IUPAC system, that is International Union of Pure and Applied Chemistry. right? So aliphatic carboxylic acids, they are named as alconoic acid. Okay, they are named as alconoic acid. Please remember this. Okay, so whatever important things I've been telling you from day one, I'm telling you, please note it down. Okay, please note it down. So whatever important things I've been told, so you have to note it down. You have to make, because as you all know, chemistry is a volatile subject. Okay, it will easily get evaporated from your head. So so if you write it, so somewhere when you read again, you will understand, or you can recall all the things again. Okay, so you have to write down this important point. So aliphatic carboxylic acid, they are termed or they are named as alconoic acid. Okay, so the simplest what you can say aromatic acid is your, what is this? Yes, what is this? So your, what is happening here? See here, if I have a alkane, okay, if I have your alkane, your Ne will be replaced by oic acid. Okay, sorry, not Ne, your E. Okay, your E will be replaced by your E. E will be replaced by what? Oic acid. So this is the term. Now what is this? This is a benzene ring. So benzene is there. So what I'm going to do in benzene, what I'm going to do, benzene. So this is benzoic acid. Okay. So I'm going to keep this as benzoin, benz, okay, and oic acid. So the name of this compound is benzoic acid. So this is the simplest aromatic acid. So this is the simplest aromatic acid. So very simplest aromatic acid. Okay, so your aliphatic carboxylic acid, they are termed as alconoic acid. Okay, and benzoic acid is the simplest aromatic acid. So let us see now some of the compounds, okay, and how to name these compounds. So yes, now here you can see if you have one carboxylic group, then they are termed as oic acid. If you have two carboxylic acid groups, then it is dicarboxylic acid. If there are three carboxylic acid group present in the molecule, then it is tricarboxylic acid. Okay, so this you have to remember. Okay, let us go for the next one. Okay, I'll give you the compound names. Okay, you have to try to name these compounds. Okay, so let us name these compounds now. So let us start with the simplest one. Okay, so the IUPAC system. So first one is compound. Next will be your, okay, compound. Then is your common name. Okay, common name. And next is your IUPAC name. Okay, so compound, let me write the structures. So the first one is H, C double bond O, OH. Okay, second one, CH3, COOH. Third one, CH3, CH2, CH2, COOH. Yes, start naming the compounds. Fourth one, CH3 twice, CHCOOH. Then fifth one, COOH and COOH. Sixth one, COOH, CH2, COOH. Seventh one, COOH, CH2 twice, COOH. Eighth one, COOH, CH2 thrice, COOH. Ninth one, COOH, CH2 4, COH. Okay. So tell these many names first. Yes, first one. What is the name? First one. Yes. What is the name of the first one? Try to name it. First one. Okay. So should I tell it? So the first one is, so we have seen this compound in like this, right? In the aldehydes ketones. So we have seen this compound like this, CH, right? So what was the name there? The name was formaldehyde. So here the common name is formic acid. So the common name is formic acid. Okay, yes, very good. Lubna has answered it. And the IUPAC name is, there is one carbon. So whenever you have one carbon, it is methanoic acid. Okay, not methanol. It is methanoic acid. Okay, your E will be replaced by oic acid. Okay, your E will be replaced by what? Oic acid. Okay, next one. Next one. Next one. The name is acetic acid. Common name is acetic acid. Please give the IUPAC name. So two carbons are there. So two carbons means it is ethanoic acid. Okay, it is ethanoic acid. Okay. Next one, 4 carbons are there. Okay, 4 carbons are there. So it is butyric acid. Okay, it is butyric acid, common name. IUPAC name. Yes, now you can tell the IUPAC name. 4 carbons are there. Your E should be replaced by oic acid. So what is the name? So it is butanoic acid. Butanoic acid. Okay. Then next one, mark this as important. Mark this as important, asked for exams. Okay. What is the name? What is the name? So it is something like this. CH3, CH, CH3, COH. Yes, what is the name? It is how many carbons are there? 4. So it is isobutyric acid. Okay, it is isobutyric acid because this carbon is secondary carbon. Right, this carbon is secondary carbon, so it is isobutyric acid. Isobutyric acid. What is the IUPAC name? So it is, yes, 1, 2, 3. So it is 2-methyl, 2-methyl, 2-methyl propanoic acid. Propanoic acid. Okay. So please understand. Okay, whatever I'm telling, please understand. So this question can be asked. Okay. Fine. So let me clear this. This, yes, fifth one. What is the name? You have two COH group. You have two COH group. So it is oxalic acid. The common name is oxalic acid. And what is IUPAC name? It is ethane dioic acid. Ethane dioic acid. Okay, next one. It is malonic acid. Okay, it is malonic acid. The name is propane 1,3-dioic acid. Okay, 1,3. So 1, 2, and 3. So 1,3-dioic acid. Got it? So ethane 1,2-dioic acid, and this is ethane, propane. 3 carbons are there. So propane 1,3-dioic acid. Next one. This is succinic acid. Okay, this is succinic acid. What is the name? IUPAC name. So 1, 2, 3, and 4. 1, 2, 3, because your number of carbon atoms are 2, right? So 1, 2, and 3, and 4. So this is butane 1,4 dioic acid. Okay, next one. So 1, 2, 3, 4, 5. So this is what? Glutaric acid. Glutaric acid. Okay. Then the name is pentane 1,4 dioic acid. Next one. 1, 2, 3, 4, 5, 6. 4 carbons are there. Here 3 carbons are there. So this is adipic acid. Adipic acid. Common name is adipic acid. This is 6 means it is hexane 1,6 dioic acid. Okay, next one, 10th one. You can tell me. So this is 1, 2, 3, 4, 5, 6 carbons are there. Just a second now. Now here 1, 2, 3 carbons are there, right? So these can be taken as a substituents. These can be taken as their substituents like this. I can write it like this also. Just a second. I'll show you. Right. So what is the name? So no common name. So it is propane 1, 2, 3, 1, 2, 3 trioic acid. Yes, 1, 2, 3 trioic acid. Okay. Next compound. Yes, what is the name? Common name? Benzoic acid. And your this, what is its IUPAC name? It is benzene and a carboxylic acid. Benzene carboxylic acid. Okay, then next, last one, COOH and COOH. Yes, what is the name of this? Phthalic acid. Okay, so this is phthalic acid. So this compound is phthalic acid. So when you have a benzene, 1, 2 substituted carbon. Okay, when you have a benzene and 1, 2, 1, 2 position, you have a carboxylic group, then it is a phthalic acid. PH, PHALIC, phthalic. Okay, phthalic acid. Can you tell the common name? Can you try the common name? Yes, anybody wants to try the common name? The common name is what? Benzene. Then at 1, 2 position, you have carboxylic group. So it is 1, 2 dicarboxylic acid. Okay, 1, 2, 1, 2 dicarboxylic acid. Is it clear now? Is it clear about the name system? How to name, I give the IUPAC name? Yes, everyone. So if you don't know the this common, they'll not ask you in exam common names. They'll ask you the IUPAC name. Okay, so IUPAC name you have to study. Got it? Yes. Okay, fine. Others? Fine. So shall we move for the next one? So next we are going to see the structure. Okay, so these are all things we have discussed. So let us go for the structure of carboxyl group. Okay, let us discuss the structure of carboxyl group. So, so you can see the structure of carboxyl group. Okay, so this is a structure So you can see C double bond O and H. So here there are two lone pairs. Here also there are two lone pairs. Right. Now here you can see that the hybridization, okay. So the hybridization of the carbon, so the hybridization of carbon is what? It is sp2 hybridized. Okay. So the carboxyl carbon, okay, the carboxyl carbon is what? It is sp2 hybridized and it is planar. And this is planar. Okay. It is planar with a bond angle of, so this is planar. This is sp2 hybridized and it is planar with a bond angle of 120 degree. Okay, it has a 120-degree bond angle. Okay, so each bond here it is 120 degree. So what you can say that the carboxyl carbon is sp2 hybridized. It is a planar compound. Okay, with a bond angle of 120. With a bond angle of what? 120. So here, when you can see the how it undergoes a resonance stabilization. Okay, so how it undergoes resonance stabilization. So this oxygen is sp3 hybridized, right? Oh, this carbon is sp2 hybridized. This oxygen is also sp2 hybridized. Okay, so this is the hybridization of each atoms in this particular structure of carboxyl group. Now, how it undergoes hybridization? Okay, how it undergoes resonance stabilization. Just see. So these are the lone pair of electron. So it is having a conjugate system. Okay, so the lone pairs are involved. So what will happen? This oxygen will get what? Negative charge. Okay, so this will get, because the pair of electrons are transferred on the oxygen. Okay, in turn, the carbon will get a positive charge. Okay, this will get a positive charge. Now what will happen to stabilize this charge? Okay, positive charge, again bond movement will occur. Okay, bond movement will occur, and what you will get? You will get here oxygen will have a positive charge with the lone pair of electrons. So this is the resonance structure of your carboxyl group. This is the resonance structure of your carboxyl group. So the carboxyl carbon is less electrophilic. Okay. So as compared to the carbonyl carbon, this is less electrophilic. This is less electrophilic as compared to your carbonyl carbon. Okay. Because of this resonating structures, you can see that they are less electrophilic in nature. Okay, let us see the methods of preparation. So, okay, so let us start with the methods of preparations. Okay, so what are the methods of preparation of carboxylic acid? So, how we can prepare different carboxylic acid? So, how we can prepare different carboxylic acids? Okay. So first one is from primary alcohols and aldehydes. So by taking primary alcohols and aldehydes, we can prepare our carboxylic acid. So let us see. So let us see. Okay. So primary alcohols, when we take a primary alcohol, so here you can see one primary alcohol has been taken. So we are doing oxidization. We are doing oxidizing. By using oxidizing agents, we are going to oxidize it to carboxylic acid. So our primary alcohols are there. Primary alcohols is converted into carboxylic acid. So which is the primary alcohol taken here? So if I give you general reaction, so let me take like this. So RCH2OH, when it is treated, so we can use for primary alcohols, which are the different oxidizing agents which we can use is KMNO4, okay, in the alkaline medium, KMNO4 in the acidic medium, and K2Cr2O7 in the acidic medium. So these are the different oxidizing agents from where we can convert our primary alcohol into carboxylic acid. Okay, so this can be converted. Now here, so if we take here, so let me take alkaline KMNO4. So alkaline alkaline KMnO4, okay, followed by hydrolysis. Okay, followed by hydrolysis, we yield you what? You will yield the carboxylic acid. Okay, you will yield the carboxylic acid. So this is our primary alcohol. Yes, this is our primary alcohol. So we have treated with KMnO4 in the presence of alkaline KMnO4, followed by hydrolysis. Okay, what we are going to get? We are going to get a carboxylic acid. So here the number of carbon atoms are 3. Here also 3. So this group will be, what will happen? The hydrogen will be removed and oxygen will be added. Okay, so you will get a carboxylic acid. So here you can see the example. So this is one example. Okay, this is one example. Let me give you one more example. So you have to tell me the answer. So CH3, CH2 8 times. Okay, CH2 8 times. Then CH2OH. Okay, I'm going to treat it with, I'm going to treat it with alkaline KMnO4. Yes. What will be the product? What will be the product obtained, students? What is the name? So 8 carbons are there. 8, 9, 10 carbons are there. So it is decanol. Okay, 10 means deca, 8 means octa. So there are 10 carbons. So it is decanol, 1 decanol. Okay, so 1 decanol. So 1, 8. So this is 10th one. So these are 8 carbons, right? So 1 decanol. What will obtain? What will the product obtain? Students try. So what you'll get? You will get CH3, CH2 8 times and COH. Your CH2OH group will be converted into COOH group. Okay, so this is the first method of preparation of a carboxylic acid from a primary alcohol. Okay, from a primary alcohol. Is it clear? Yes, is it clear? So this is the first method of preparation of primary alcohol. Okay. Now, if you want to prepare our aldehydes, okay, now I want to prepare aldehydes. So which are the different oxidizing agent? I hope you are noting down this, okay, very important. So please note it down. So for primary alcohol, which are the different oxidizing agents which we can use, and for conversion of aldehydes to carboxylic acid, which are the different oxidizing agents which we are going to use. So we are going to use your chromic acid. Okay, we are going to use your chromic acid. Then we are going to use pyridinium chlorochromate, that is PCC. Pyridinium chlorochromate, that is PCC. Next, we are going to use pyridinium dichromate, PDC. Pyridinium dichromate, that is PDC. Jones reagent. So please mark this as important. What is Jones reagent? So Jones reagent is what? When you have a chromic acid in the presence of H2SO4 and acetone. Okay. So H2SO4 and acetone, you will get what? You will get Jones reagent. So what is Jones reagent? So Jones reagent is CrO3 plus H2SO4 in acetone. Okay, so these are the different reagents which you have to remember. Okay, so what we are going to take a aldehyde. We are going to take a aldehyde. Now this aldehyde I have treated with PCC. So I have taken here pyridium chlorochromate. Okay, what I'm going to get? Your aldehyde group is converted into carboxylic acid. Your aldehyde group is converted into carboxylic acid. So hydrogen is removed, oxygen is added. Okay, so you know what is oxidation, what is reduction in terms of hydrogen and oxygen. Okay. So this was the first preparation method of preparations. Okay, for your carboxylic acid. Second one is from alkyl benzenes. From alkyl benzene. So aromatic carboxylic acids, it can be prepared by vigorous oxidation, okay, of alkyl benzenes with chromic acid, okay, or acidic or alkaline potassium permanganate. So your alkyl benzenes. Alkyl means alkyl substituted benzene ring. So this is what? This is a toluene. Okay, this is a toluene. So toluene or your methyl benzene, you can call it as methyl benzene, right? So what we are going to do, we are going to treat our alkyl benzenes with either we can use chromic acid, that is CrO3, okay, in the presence of H2SO4, or we can use our KMNO4, okay, in the presence of H plus ions, or we can use a KMNO4 in the alkaline medium. So these are the different oxidizing agents which we can use for converting our alkyl benzenes, okay, into carboxylic acid. So here we are going to treat, okay, so here we have treated with KMNO4 in the presence of a base, alkaline base we have taken as KOH, okay. That is a strong base, it is potassium hydroxide, and we are going to heat. What we are going to get? We have to get a potassium benzoate. Okay, we are going to get a potassium benzoate salt. Okay, we have got a potassium benzoate salt. So our CH3 is converted into COO. Our hydrogens are replaced by oxygens. Okay, because we are doing oxidation. So what is happening? Your methyl group is converted into, so our methyl group is converted into what? Methyl group is converted into a carboxy group. Okay, so that is a potassium salt of benzoate. Okay, this is a salt form. This further undergoes hydrolysis. This will further go what? Hydrolysis to give you what? Benzoic acid. Simplest acid, aromatic acid, that is a benzoic acid. Okay, one more example. So here we have taken N-propyl uh, N-propyl group is there, right? So propyl benzene, N-propyl benzene, we are going to treat it with what? KMNO4 in the presence of KOH, and we are going to heat it. So what will happen? So this we are going to get a, so this whatever the side chain is there, how many number of side chains are there? Okay, so the entire side chain is oxidized to carboxyl group. Okay, it is converted into carboxyl group. So we have taken here potassium salt, so it became potassium salt of benzoate. If you take here NaOH, then what I'll get? I'll get Na. Okay, so sodium benzoate I'll get. Okay, so depending upon what base you are taking, so you have to form that particular salt. So irrespective of how many number of carbon atoms are there on the side chain, okay, of the carboxyl group, okay, so that is converted into carboxyl group. So the side chain is oxidized to carboxyl group. And so what we get here again, we are going to get the potassium benzoate. So we got a potassium benzoate. This potassium benzoate, we are going to do hydrolysis to get to benzoic acid. So irrespective of how many number of carbon atoms are present on the side chain, it is converted into potassium, that is carboxyl group. Okay, it is converted into a carboxyl group. Got it? So only primary and secondary alkyl groups can be converted. So in this conversion of your alkyl benzenes to your carboxylic acid, okay, so it can be done only on primary and secondary alkyl groups. Okay, on the primary and secondary alkyl groups. So only primary and secondary alkyl group can undergo oxidation. Tertiary, okay, tertiary will not undergo oxidation. So they will not undergo oxidation. So only we can use primary and secondary alkyl group. So this was the second method of preparation. Is it clear? So is it clear? Second method of preparation of carboxylic acid. So we are taking a alkyl groups. What we are going to take? We are going to take a alkyl group. So from that alkyl group, we have what we have done. We are going to convert it into a salt form. Okay, respective salt form, and then we are going to hydrolyze it to give you a acid. Okay, irrespective of how many this is there, number of carbon atoms are present on the side chain, it is oxidized to what? It is oxidized to carboxyl group. Okay, is it clear? Next is from nitrile and amides. Next is from nitriles and amides. Okay. Next is from nitriles and amides. What is a nitrile? Yes, students, what is a nitrile? Cyano group, right? Cyanides are called as nitriles. Cyanides are called as what? Nitriles, right? Cyanide, CN group. So this is a nitrile group, right? This is what? This is a nitro group, right? Nitrile group. So what we are going to do, we are going to take nitrile and we are going to hydrolyze to amide. Okay. So nitriles, what we are going to do, nitriles are there, C double bond N. So when we do hydrolyzation, okay, we are going to do hydrolyze to them to amide form. So we are going to amide. So this is our nitrile. So after doing, uh, we are hydrolyzing it. Okay, after undergoing hydrolysis, okay, we are hydrolysis means what? Addition of water molecule. What we are going to get? We are going to across this C double bond N. Okay, so here your oxygen is added and here your uh, H2 is added. Okay, so H2. So H plus and OH minus. So water molecule is added. So H2O. So across your cyanide, oxygen is added. Across your nitrogen, H2 is added. So what we get a amide system. This amide, okay, again, they are converted into acid, carboxylic acid in the presence of H plus or OH minus ions. Okay, that is used as a catalyst. We are going to heat it. We are going to heat it. So here in the presence of acid or a base as a catalyst, we are going to heat it and we are going to get a carboxylic acid. So here the reaction, we can stop it at amides also. Okay, by doing mild reaction, by reacting it with a mild reagent. So by reacting with the mild reagent, we can do a what? We can do a formation of only amides. So what we are going to do? We are going to take nitriles. We are doing hydrolysis. What do you mean by hydrolysis? Addition of water. Okay, addition of water molecule. Now how we have added water? So here we have added oxygen. Here I have added H2. So we got R C double bond O N H2. Right. So amide. This further in the presence of acid or a base as a catalyst, we are going to get carboxylic acid. We are going to get carboxylic acid. Okay. So directly from amides, if you do it in the presence of acid or base as catalyst, we are going to get carboxylic acid. Okay, so here you have you can see here. So let me give you examples. Now let us see some examples. Okay, unless and until we'll do examples, you will not understand. Okay, so examples are important. So let me take CH3, C triple bond N. Okay, so do hydrolysis on that in the presence of H plus or OH minus. Okay, so what you are going to get? So this is your ethane nitrile. This is your ethane nitrile. Yes, students, please tell the answer. So this will be CH3, C double bond O, NH2, right? So this is what? Acetamide. This is your acetamide. This acetamide further will undergo H plus in the presence of H plus and OH minus. We have to heat it. What we are going to get? We have to get a acetic acid. Okay, plus NH3 gas is evaporated. Okay, so this is acetic acid. So this is the example. Okay, so from nitrile, we are converted into amide, from amide into acid. One more. So this was aliphatic. Let us see, take a aromatic ring. Yes. So this is benzene nitrile. This is benzene nitrile. Again, add water into presence of H plus and OH minus. What we are going to get, just see. So here we are going to get oxygen. Here we are going to add H2. So we are going to go get what? Benzene, C double bond O, N H2. So this is what? Benzamide. This is benzamide. This benzamide further heated with H plus or OH minus. What we are going to get? C double bond O, H plus NH3. So this is what? Benzoic acid. What we got? Benzoic acid. Are the examples clear? Yes, is it clear, students? how we are going to prepare our carboxylic acid from nitriles and amides. Yes, is it clear? Any doubts? So we have seen three methods of preparation. The first one was by doing a Okay, first one was by doing a oxidation on primary alcohols. Okay, primary alcohols to carboxylic acid. Then second one we have seen uh, by doing a oxidation on aldehydes to carboxylic acid. Okay, so by from primary alcohols and aldehydes, we by doing oxidation we get carboxylic acid. So this was the first method of preparation. Second, from alkyl benzenes. Okay, so alkyl benzenes, if we treat it with your chromic acid in the presence of H2SO4 or KMNO4 in the acidic or basic medium, we are going to yield benzoic acid. Okay, irrespective of how many carbon atoms are present on the side chain, it is going to be converted into carboxylic group. Then the third was from nitriles and amides. So nitriles and amides by doing hydrolysis, okay, we are going to yield nitriles, we are converting into amides. Then by the presence of acid or a base as a catalyst, we are going to convert it into carboxylic acid. So this is the methods of preparations of your this what carboxylic acids. Okay, is it clear up to here? Fine. So we have one, two, three. So three more are there. So let us do in tomorrow's class. Okay. Three more these are there. Methods of preparations are there. So that we can do in tomorrow's class. Okay. Again, there should not be much confusion. So can you tell me what is Grignard reagent? Can anyone tell me what is Grignard reagent? What is the Grignard reagent? What is the formula for Grignard reagent? What is, okay, if I ask you a question, what is Grignard reagent and how do you represent Grignard reagent? Okay, how will you answer it? Okay, so this is a 2 marks question. What is Grignard reagent and how will you represent Grignard reagent? So 2 mark question. What is Grignard reagent and how do you represent Grignard reagent? Yes, 2 questions, 2 marks. So each question you will get 1 mark. So what is Grignard reagent? Anybody? Yes. Nobody knows what is Grignard reagent. So from haloalkanes, haloarenes, steel alcohol, phenols, and ethers, and in this chapter also. So in all the chapters, Grignard reagent is there only. We are dealing with Grignard reagent in all the organic chemistry. How? Yes. What is Grignard reagent? Very important question. I think in first year also you have discussed about Grignard reagent. Yes, you have discussed about Grignard reagent in first year also. Yes. What is Grignard reagent? Okay. So nobody knows. So please notice down. What is Grignard reagent? Grignard reagent is called as organo no Organometallic compounds are called as Grignard reagent. Organometallic compounds are called as what? Grignard reagent. This is the first answer. What is Grignard reagent? Organometallic compounds are called as Grignard reagent. How it is represented? RMgX. RMgX. Okay. So how is Grignard reagent represented? RMgX. So any point of view, if I ask you, you should be able to tell me. Can anyone tell me what is Lucas reagent? What is Lucas reagent? Anybody knows? So these are some of the important questions, okay, which is used, which is repeatedly asked in chemistry, either in the MCQ forms or in the fill in the blanks form for 1 mark type of questions. So these are some of the important questions. So this you have to know. No need to study. What is Lucas reagent, students? This we have discussed in alcohols, chapter alcohols. Okay, somebody has answered. Very good. Baby has answered. So it is concentrated HCl and anhydrous ZnCl2. Okay, fine. Very good. Okay. Can anyone tell me which is a dehydrohalogenating agent? Okay, let me write it clearly. Which is a dehydrohalogenating agent? Which is a dehydrohalogenating agent? So these questions you have to keep in mind. So now at any point, I'll be asking such questions, small questions. Okay. Which is a dehydrohalogenating agent? Which is a dehydrohalogenating agent? Don't know? Alcoholic KOH. Okay, remember this. Alcoholic KOH is a dehydrohalogenating agent. What do you mean by dehydrohalogenating agent? Removal of hydrogen and a halide, okay, molecule. So removal of, okay, elimination of hydrogen and a halogen, that is HX. Okay, it can be any halide group atom. Okay, so alcoholic KOH. So these three questions. So today you have learned how many? So 2 marks, 3 marks, 4 mark question. So you have we have studied some important 4 marks question. So at any point, if I ask you this particular question, now you should be in the position to answer this. Okay. So next time, if I ask you this question and nobody answers, okay, then it will be very difficult for you. Okay. So remember this, very important. So now at any point, if I ask you, you should be able to tell. Okay. So Lucas reagent is concentrated HCl and anhydrous ZnCl2, zinc chloride. What is Grignard reagent? Organometallic compounds are called as Grignard reagent. How it is represented? RMgX. Okay, and what is a dehydrohalogenating agent? Alcoholic KOH is called as a dehydrohalogenating agent. Fine? Okay. Fine. Then the rest all things, let us see in the tomorrow's class. Okay. Fine. So please go through the things which have been told. If you find any difficulty, you can ask me in the tomorrow's class. Okay. Fine. Okay. So I'll end the session here. So we'll meet in tomorrow's class. Thank you. Have a good day.